Alright guys, so I'm here to go over 9-4 PowerPoint. I did intro to 9-4 a couple of days ago. I don't really know how we're going to set it up, but here is a official lesson on 9-4 quadratic equations, perfect square trinomials. So, hope you remember perfect square trinomials. They look like this. I have the quantity of a plus b squared. So I have a squared plus 2ab plus b squared. I also have a squared minus 2ab plus b squared. And that can be factored into the quantity of a minus b squared. So I had the difference of squares and the sum of squares. So I got 4x squared plus 12x plus 9. I know that the square root of 2x squared is 2x. And then the square root of 9 is 3. If I multiply 2x times 3 together, I get my middle term of 6x, which turns into 12x. So a plus b is just going to be 2x plus 3, and that quantity squared. For this difference of squares, I have 16t to the 4th minus 8t squared u cubed plus u to the 6th. If I square root 16t to the 4th and u to the 6th, I get 4t squared and u to the 3rd. A minus b, that quantity ends up being 4t squared minus u cubed squared. So we did that with the Xbox method. Now, it says recognize and factor perfect square trinomials. Knowing how to do that doesn't really help you much if you don't have a perfect square trinomial. So, you have to determine whether each trinomial is a perfect square trinomial, right, yes or no, and if it is, you're going to factor it. So there's 3 questions that you're going to ask yourself. So here's my example. I have 9y squared plus 24y plus 16. The first question, is your first term a perfect square? So is 9y squared a perfect square? If I square root 9, I get 3. And if I square root y squared, I get y. So the answer to that question is yes. The second question, is the last term a perfect square? So we filled out a perfect square chart to help you recognize them. We should know by now that 16 is a perfect square. That is 4 squared. And the last question, is your middle term equal to 2ab? So my a is 3y and my b is 4. So does 3y times 4 give me 24y? And it does. So this is a perfect square trinomial. So I remember it's going to be a plus b squared, the quantity of a plus b squared. So my a is 3y, my b is 4. So this is going to be 3y plus 4 squared. So that's why it's super important to recognize perfect square trinomials. It saves you a lot of work. So, next example, I've got 16y squared minus 6xy plus 4y squared. This is a difference of squares because I have a negative middle term. So first question, is my first term a perfect square? If I square root 16x squared, I do get 4x. So the answer to that is yes. Is my last term a perfect square? The square root of 4 is 2, and the square root of y squared is y. So the answer to that is yes. And then my last question, is my middle term 2 times a times b? So a is 4x and b is 2y, so 4 times 2 is 8xy. Does that equal 6xy? It does not. So this is not a perfect square trinomial. So we can't factor it yet. Here are 2 your turns. So take a minute, you can pause the video and work those out and decide if they are perfect square trinomials. If they are, then you should factor them. All right, example 2. Solve equations with repeated factors. So let's look at this. I've got 9x squared minus 48x is equal to negative 64. So the first thing that you should recognize is the fact that you have an equal sign. So far, we've only been given an expression. Now we have an equal sign. So the first step that you're going to do is you're going to add 64 to both sides. And then if I add 64 to both sides, my equation is now going to equal 0. I got 9x squared minus 48x plus 64 equals 0. Then I have to ask myself, is this a perfect square trinomial? Is my first term a perfect square? The square root of 9x squared gives me 3x, so the answer to that is yes. And then you ask yourself about your last term. Is that a perfect square? The square root of 64 is 8, so yes. And then is your middle term 2 times a times b. So 3x times 8 times 2, does that give me negative 48x? The answer is yes. So I'm going to recognize this as a perfect square trinomial. So my a is 3x, my b is 8. I'm going to write this as 2 factors, 3x minus 8, and I square it. Remember, I can expand it to look like this, 3x minus 8 times 3x minus 8. Notice the example says we are going to solve. So we want to set both of these expressions equal to 0. So 3x minus 8 equals 0. So set the repeated factor equal to 0. Now this is just a two-step equation, so I'm going to add 8 to each side and then divide by 3, and I get x is equal to 8/3. So I have solved this equation because it has repeated factors. There are 2 your turns. Notice in A, it is already set equal to 0. And then B, you have to set it equal to 0 before you can start factoring it if it is a perfect square trinomial. So go ahead and pause this video and work that out. Alright, here is a square root property. It's a key concept. To solve a quadratic equation in the form x squared equals 9, you take the square root of each side. For any number that n is greater than 0, if x squared is equal to n, then x equals plus or minus the square root of n. This symbol, the plus over the negative, means you will have a positive and a negative answer. So x squared equals 25. If I square root both sides, I get 5. We have to remember that a negative times a negative gives you a positive, so that's why your x could either be a positive 5 or a negative 5 because of those integer rules. This is the square root property. So now, it says use the square root property. I've got y minus 6 squared is equal to 81. It's my original equation. Now I'm going to remember the square root property. To get rid of something that is squared, the inverse of that is to square root. So if I square root both sides, I would get y minus 6 is equal to plus or minus 81. I got to remember that the square root of 81 is 9. So y minus 6 could either equal plus 9 or minus 9. So what I can do is I can add 6 to both sides, and then I have to separate it into 2 equations. So I would get y is equal to 6 plus 9 or y is equal to 6 minus 9. Notice you have a plus 9 and a minus 9. So I solve for both. I get y is equal to 15 or y is equal to negative 3. The roots are 15 and negative 3. The roots, it's probably a little unfamiliar to you, but that is just the answer to a a problem like this using the square root property. Whenever you solve trinomials by factoring, you will get roots. We'll talk about that later with quadratics. Example 3, we're going to use the square root property. So I have x plus 3 squared is equal to 20. Notice here that the square root of 20 is not a perfect square. So here we separate that 20 into 4 times 5. And then the square root of 4 is 2. So you're left over with 2, the square root of 5. So now I'm going to subtract 3 from both sides. I split it into my two equations, and I get these ugly roots. I got negative 3 plus 2 times the square root of 5. Then I have negative 3 minus 2 times the square root of 5. That is how you should leave your answers. You do not want to put them in decimal form because they are not pretty numbers. That's why we leave them with the square root. Alright, here are 2 your turns. So pause the video and work on those. Alright, last example. Solve an equation. Physical science. During an experiment, a ball is dropped from a height of 205 feet. The formula h equals negative 16t squared plus h naught can be used to approximate the number of seconds t it takes for the ball to reach height h from an initial height of h naught feet. Find the time it takes for the ball to reach the ground. This is a formula that you will see when you get into physics. The h with a subscript of 0, we call that h naught. So we want to solve this. We know that the ground has no height, so h should equal 0, and the initial height is 205 feet. So our original equation should be h is equal to negative 16t squared plus h naught. We know my initial height is 205, and the height where you're dropping from is 0, which is the ground. And then I'm going to subtract 205 from both sides to get my t squared closer to being by itself. Then I divide both sides by negative 16. And then I think about my square root property. Anytime I square something, I have a positive and a negative answer. So I've got the positive or negative 3.6. Notice it doesn't say it equals t, it is approximately t. But now we have to think about the context of this problem. It is talking about height and time. So here it's telling us that 3.6 seconds or negative 3.6 seconds to reach that height or reach the ground. So obviously you can't have negative time. In the context of this problem, you will only have one root, which is approximately 3.6, just because you can't have negative time. So here it says write down the following problems on your own sheet of paper. So this is what you're going to be working on. There is a practice on what we just learned. They are the same as what is at the end of this PowerPoint. So show your work on paper. It says be sure to use Shift 6 for exponents and do not type spaces. And then the last 4 here says check for a GCF first. That is super important because once you take out the GCF, you should find that you have something that is more manageable. As always, if you have any questions, you can email one of your math teachers. Thank you.